Yes, it's Salah Nasri here, and yes, I have a special announcement. The Game of Chips has just hit 5,000 orders on Amazon. Thank you to everyone who placed the order. The book was just released in December, so I'm very, very grateful and surprised to date. If you are someone who is intrigued, curious about how the semiconductor ecosystem works from beginning to where we are right now, this book was written with you in mind. So order it, read it, and it is pretty much a handbook of the whole ecosystem. In the meantime, enjoy the next episode and don't forget to hit that subscribe button. Hello and welcome back to the Semiconductor Leadership Podcast. I'm your host, Salah Nasri, and yes, I have received the messages on redoing and going back to the quick chip episodes. And for the next few weeks, we'll be doing full deep dives into companies that occupy the most strategical, powerful positions in the entire semiconductor industry. Today, we'll be talking about a specific company that operates so far upstream in the chip making process that even many tech professionals don't appreciate what it really does. Today, we're going to be talking about Cadence Design Systems, ticker symbol CDNS on the NASDAQ. So here's a thought experiment. Before a chip is fabricated, before a single transistor is etched onto silicon at TSMC or Samsung or Intel or GF or Skywater, that chip has to be designed. Every one of the billions of transistors need to be placed. Every wire routed, every timing constraint met, and every electrical interaction simulated and verified. The complexity is staggering. A modern AI processor can contain over 100 billion transistors, and designing something like that without software tools would be like trying to build a city of 100 billion buildings using nothing but pencil and paper. It's physically impossible. The software tools that make chip design possible today are called electronic design automation, EDA. And Cadence is one of the two companies that dominate this market alongside Synopsys. Together, they control roughly 60% of the global EDA market, with Cadence holding approximately 30% share. Behind them is Siemens EDA, formerly known as Mentor Graphics, and they hold about 13%. But calling Cadence just an EDA company would be calling Apple just a phone company. Under the CEO, Anirudh Devgan, Cadence has transformed itself into what it calls a computational software company, one that spans chip design, hardware verification, semiconductor IP, system analysis, and increasingly, AI-powered autonomous design. It ended fiscal 2025 with $5.3 billion in revenue, a $7.8 billion backlog, and a market cap well north of $75 billion. Today, we're covering the full story. The founding, the EDA industry dynamics, Cadence's technology portfolio from Virtuoso to Palladium, the AI transformation with Cerebrus and ChipStack, the system design expansion. We'll also look at the financial model and the competitive battle with Synopsys for the soul of semiconductor design. So let's get into it. To understand Cadence, you have to understand the birth of the EDA industry in itself, because the two stories are inseparable. In the early 1980s, the semiconductor industry was hitting a wall. Chips were getting complex enough that the traditional method of designing them, largely manual schematic capture and hand layout, was becoming untenable. So the industry needed software tools that could automate the tedious, error-prone aspects of chip design, placing components routing wires, checking design rules, and simulating circuit behavior. Semiconductor companies emerged to fill this need. So in 1982, a company called ECAD, which was co-founded by Ping Chao, Glenn Antor, and Paul Huang. A year later, in 1983, Solomon Design Automation, SDA, was founded in San Jose by James Solomon, along with prominent UC Berkeley academics Richard Newton and Alberto Sangiovanni. Vincentelli, I hope I pronounced that right. Two pioneers whose research had laid the theoretical foundations for computer-aided chip design. So in 1988, SDA and ECAD merged to form Cadence Design Systems, with Joseph Costello appointed as CEO of the combined entity. The merger created a company with a comprehensive suite of EDA tools and the scale to compete in what rapidly became a critical infrastructure market for the semiconductor industry. What happened was that Costello moved aggressively to consolidate the fragmented EDA landscape. In 1989, Cadence acquired Gateway Design Automation for $72 million, a deal that brought with it a little product called Verilog, which would go on to become one of the two dominant hardware description languages used to design chips worldwide. That single acquisition gave Cadence a foundational technology that remained central to chip design decades later. Over the following years, Cadence continued to acquire and develop technologies across the full spectrum of chip design, from analog and mixed signal design to digital synthesis, from physical layout to timing analysis, from simulation to formal verification. And by the late 1990s, Cadence had established itself as one of the big three EDA companies, alongside Synopsys and Mentor Graphics. The company went through leadership transitions. It was Ray Bingham, then Lip-Bu Tan, who served as CEO from 2009 to 2021. And Tan's tenure was actually transformative. He refocused the company on technical excellence, deepened relationships with leading-edge customers, expanded into IP and system design, and set the stage for the AI-driven growth that would come next. So let me paint a clear picture of what EDA software actually does, because the elegance and criticality of this market are underappreciated. Designing a modern semiconductor indeed is one of the most complex engineering tasks humans undertake. The process involves multiple stages, each of which requires specialized software tools. First, there's architectural specification and RTL design. This is where engineers describe the chip's behavior using hardware description languages like Verilog or VHDL. Cadence's Xcelium simulation platform is a leader here, enabling engineers to verify that their design logic is correct. Then comes synthesis, and that's basically translating what behavioral description into a netlist of actual logic gates. This is followed by place and route, which is physically arranging millions or billions of gates on the chip and connecting them with metal wires across multiple layers while meeting timing, power, and area constraints. Cadence's Innovus platform is one of the industry's leading place and route tools. Throughout this process, you need verification, confirming that the design actually works as intended. This happens at multiple levels. You have functional simulation, formal verification, power analysis, timing sign-off, and of course, electromagnetic analysis. The verification challenge is so enormous that it's estimated that 60 to 70% of the total effort in a chip design project goes into verification and not in the design itself. And then there's analog and mixed signal design, where Cadence's Virtuoso platform has been the gold standard for decades, designing the analog circuits, the data converters, the radio frequency components, the power management blocks, which all require a different kind of tool than digital design. And Virtuoso has been the tool of choice for generations of analog engineers. The business model is remarkably attractive as well. I mean, EDA software is sold primarily through multi-year subscription licenses, typically 3 years in duration, actually. This creates highly predictable, recurring revenue with strong customer retention. Switching costs are enormous. The chip design team might spend years mastering a particular tool flow, building libraries and methodologies around it. So changing EDA vendors mid-project is essentially unthinkable, and even switching between projects carries significant retaining and requalification costs. The result is a business with gross profit margins above 90%. I mean, operating margins in the 40s and extraordinary revenue visibility. Cadence entered fiscal 2026 with 67% of its guided revenue already in backlog. And that's the kind of predictability most software companies can only dream. Most important and most profitable parts of a Cadence's business is something that doesn't fit the typical image of a software company: hardware. The Cadence Palladium emulation system and Protium FPGA prototyping system are massive computing platforms that chip designers use to verify their designs before committing to manufacturing. As chips have grown to billions and tens of billions of transistors, software simulation alone has become too slow to fully validate a design in a reasonable time frame. Running a complete simulation of a modern SoC could take weeks or months using software alone. Hardware emulation solves this by mapping the chip design onto specialized hardware. So you've got arrays of custom processors or FPGAs that can actually execute the design at speeds thousands of times faster than software simulation. And that's Palladium. Palladium is Cadence's emulation platform, and it's one of the two dominant products in the market, competing with Siemens's Veloce. The latest generation, Palladium Z3 and Protium X3, delivered more than a 2x increase in capacity and 1.5x improvement in performance over the previous generation. They scale from 16 million gates to an extraordinary 48 billion gates, meaning the largest SoCs and entire system-on-chip complexes can be emulated as a whole rather than being broken into partial models. This matters enormously for AI chip designers. When you're building a chip with tens of billions of transistors that will run complex AI workloads, you cannot afford to find bugs after manufacturing. A single respin going back to fix a design error and refabricate the chip can cost $50 million to $100 million at advanced nodes and add 6 months to a year of delay. Palladium and Protium allow designers to catch those bugs before silicon, when they can be fixed in a software at a fraction of the cost. So the hardware verification business is highly profitable for Cadence and has been a significant growth driver. Hyperscale companies designing custom AI chips, be it Google, Amazon, Meta, Microsoft, are amongst the heaviest users of emulation and prototyping systems. And as the number and complexity of custom AI chips have surged, so has the demand for Palladium and Protium. Now let's talk about the dimension of Cadence's story that has Wall Street most excited about. Yep, it's the word AI. Not just AI as a demand driver, though it certainly is that, but AI as a fundamental transformation of what EDA software can do. Cadence has been at the forefront of applying artificial intelligence to the chip design process itself. The flagship product in this effort is Cerebrus, an AI-driven optimization engine that uses reinforcement learning and machine learning to automate what were previously manual, expert-driven decisions in chip design. So here's the problem that Cerebrus solves. When an engineer is designing a chip, placing blocks, routing wires, optimizing for speed and power, there are an astronomical number of possible configurations. Traditionally, a senior engineer would rely on years of experience and intuition to make design choices, iterating through perhaps dozens of configurations over weeks or months. Cerebrus can explore thousands of configurations autonomously, using AI to learn which design choices lead to better outcomes and converge on optimized solutions in a fraction of the time. So the productivity gains are substantial. Cadence reports that Cerebrus has demonstrated up to 10x productivity improvements for key design tasks, turning weeks of manual iteration into hours of AI-driven exploration. For semiconductor companies facing a chronic shortage of experienced design engineers, this kind of productivity amplification is enormously valuable. But Cadence didn't stop at Cerebrus. In early 2026, CEO Anirudh Devgan unveiled what the company calls the ChipStack AI Super Agent, an autonomous, agentic AI workflow that goes beyond optimization. ChipStack is designed to autonomously orchestrate entire chip design flows, making decisions across multiple stages of the design process without requiring constant human intervention. The concept is striking. An AI system that can take a chip specification and autonomously run through synthesis, place and route, timing optimization, and verification, exploring thousands of design permutations and converging on a solution that meets all the specifications. Engineers now shift from being hands-on keyboard designers to being supervisors and architects who set goals and constraints and let the AI do the detailed execution. Remarkable. And this is not just a feature improvement, it's a potential paradigm shift in how modern-day chips are designed. And it's a competitive weapon. If Cadence's AI tools can demonstrably reduce design time, improve chip quality, and lower engineering costs, they create a powerful incentive for customers to consolidate their tool spending with Cadence. AI-driven products such as Cerebrus, Verisium for AI-powered verification, you have Allegro X AI for PCB design, have been meaningfully contributing to Cadence's revenue growth. I mean, look at it. Core EDA grew 13% in fiscal 2025, with AI products cited as a key accelerator. Under Anirudh Devgan's leadership, Cadence has been executing on an ambitious strategic expansion that goes well beyond traditional AI. The company has repositioned itself under a framework it calls intelligent system design, a vision that extends Cadence's role and tools from the chip level to full system level. So what does this mean in practice, of course? Traditionally, EDA tools focus on the semiconductor itself. The transistors, the gates, the wires on the chip. But a chip doesn't exist in isolation. It sits on a package. which sits on a printed circuit board, which sits inside a system, a server, a smartphone, a car. The performance of that overall system depends on interactions between the chip, the package, the board, the thermal management, the power delivery, and increasingly the electromagnetic environment. Cadence has been building and acquiring capabilities to address this full system challenge. Its Clarity solver handles electromagnetic simulation of packages and boards. Its Celsius platform does thermal analysis. Its Integrity platform handles signal and power integrity. And its Optimality platform, powered by AI, automates the exploration of multi-physics design trade-offs at the system level. Now, this system design expansion represents a significant total addressable market, which is an increase for Cadence. The traditional EDA market for chip design is roughly $15 to $16 billion globally. System analysis and simulation markets add billions more. So by extending from the chip into the full system, Cadence is growing its addressable market while depending its value proposition to customers who increasingly need to co-optimize across chips, packages, and systems. I mean, look at it. The acquisitions tell the story of this expansion. Cadence acquired AWR Group. Why? It was for RF microwave design. Numica for computational fluid dynamics. Future Facilities for data center thermal management. Beta CAE Systems in 2024 for multi-physics simulation. And OpenEye Scientific in the life sciences computational chemistry space. Each acquisition extends Cadence's reach into domains where computational simulation drives engineering decisions. The system design business also benefits from the same structural dynamics driving EDA. Increasing complexity, rising design costs, and the need for AI-powered automation. So as systems become more heterogeneous, mixing multiple chip technologies, advanced packaging, optical interconnects, and complex thermal constraints, the demand for integrated system-level design tools will only grow further. Beyond EDA tools and system design, Cadence has built a substantial semiconductor IP business, its third major pillar. Semiconductor IP, or intellectual property, consists of pre-designed, pre-verified blocks of circuitry that chip designers can license and integrate into their own chips rather than designing from scratch. Think of them as Lego blocks for chip design, standardized, proven components that accelerate time to market and reduce design risk. Cadence's IP portfolio includes some of the most critical building blocks in modern chip design. High-speed interface IP like PCIe, USB, DDR memory controllers, HBM controllers, and die-to-die interconnects for chiplet architectures. These are the standardized interfaces that allow chips to communicate with the outside world and with each other. The IP business is particularly important in the context of AI and advanced packaging. As hyperscale companies design custom AI chips, they need high-performance interface IP to connect their custom compute engines to HBM memory, to high-speed networks, and to other chiplets in multi-die package. Cadence's IP portfolio, particularly its HBM and die-to-die PHY IP, is directly in the path of this demand. The financial profile of the IP business is attractive as well. IP licenses carry high margins, and many involve ongoing royalty streams as customers ship chips containing Cadence IP. The business benefits from the same switching cost dynamics and EDA costs. Once an IP block is designed into a chip, replacing it would require a costly redesign and re-verification. However, no discussion of Cadence is complete without talking about its relationship with Synopsys, because the rivalry between these two companies is one of the most fascinating competitive dynamics in worldwide technology. Synopsys and Cadence are the two dominant forces in EDA, together controlling roughly 60% of the global market. They compete across virtually every category: digital design, analog design, verification, simulation, IP, and increasingly system-level analysis and AI-powered design automation. The competition is intense, but also, in a sense, cooperative. Most semiconductor companies use tools from both vendors: a digital flow from one, an analog platform from the other, verification from a mix of both. The tools indeed are highly specialized, and no single vendor has an unambiguous lead across every category. Cadence indeed is generally considered the leader in analog and mixed signal design with Virtuoso, and is strong in place and root with Innovus. Synopsys, on the other hand, has traditionally led in synthesis with Design Compiler and has a massive IP portfolio, particularly in logic libraries and processor IP. What's shifting the competitive landscape is AI. Both companies are racing to embed artificial intelligence into their tool flows, and the company that delivers demonstrably superior AI-powered productivity gains could tilt market share in its favor. Cadence's Cerebrus and ChipStack represent one approach: AI that augments and automates the existing design flow. Synopsys has its own AI initiative, which is DSO.ai, targeting similar goals. The competitive dynamics are also being shaped by the customer themselves. Hyperscale cloud companies, Google, Amazon, Microsoft, Meta, are designing more custom chips than ever before, and they're demanding tools that can handle unprecedented complexity at unprecedented speed. These customers have the engineering sophistication to evaluate EDA tools critically and spending power to influence vendor roadmap. One important competitive event to note is actually in early 2025, Synopsys completed its $35 billion acquisition of Ansys, the simulation software giant. The deal significantly expanded Synopsys' system-level analysis capabilities, putting it in more direct competition with Cadence's own system design expansion. The competitive battle between these two companies is increasingly being fought, not just at the chip level, but at the system level. Siemens EDA, the third player, remains relevant indeed, particularly in PCB design and manufacturing engineering, but it has not kept pace with Cadence and Synopsys in the core digital and AI chip design markets. The gap between the big two and everyone else continues to widen. Let's look at Cadence's financial profile, because it's one of the most attractive in the entire semiconductor ecosystem. Fiscal year 2025 revenue was $5.297 billion, representing approximately 14% year-over-year growth. Q4 was $1.44 billion, beating consensus estimates. Non-GAAP EPS for the full year was $7.14, and the company guided fiscal 2026 revenue to $5.9 and $6 billion, implying roughly 12 to 13% growth, with non-GAAP operating margins expanding to 44.75% to 45.75% range, and EPS of $8.05 to $8.15. The quality of the revenue is sensational. Cadence's subscription model means that the vast majority of revenue is recurring. Year-end backlog stood at $7.8 billion, with $3.8 billion expected to be recognized within the next 12 months. So when 67% of your guided revenue is already in backlog before the year starts, you have a level of visibility that very few technology companies can actually match. Gross profit margin or gross margins run above 90%, reflecting the inherently high margin nature of software and IP licensing. Operating margins in the mid-40s are best in class for an enterprise software company. And they're expanding as the business scales, and AI-driven products command premium pricing. Free cash flow regeneration is robust, allowing Cadence to fund its acquisition strategy, invest in R&D, which runs at approximately 35% of revenue, and return capital to shareholders through buybacks. The balance sheet is clean, with manageable debt from recent acquisitions. The stock has been a remarkable performer. Over the past 5 years, Cadence shares have appreciated dramatically, reflecting the market's recognition that EDA is not a cyclical semiconductor business. It's a mission-critical software franchise that grows as chip complexity and design starts increase. Let's be balanced and talk about the risks. First, EDA spending concentration. A relatively small number of large semiconductor companies, the hyperscalers, the major IDMs like Intel, Samsung, and TSMC's ecosystem, the leading fabless companies like NVIDIA, AMD, Qualcomm, and Broadcom account for a disproportionate share of EDA spending. Any significant reduction in design activity among these top customers would impact Cadence. Second, the Synopsys competitive threat is real and intensifying. The Ansys acquisition gives Synopsys a system-level simulation portfolio that directly challenges Cadence's expansion strategy. And Synopsys' own AI investments means Cadence cannot take its AI leadership for granted. This is a market where technological leadership can shift within a product generation. Third, the China risk. China has been a significant and growing market for EDA tools, as Chinese semiconductor companies invest heavily in design capabilities. But US exports controls have created increasing restrictions on what EDA technology can be sold to Chinese customers, particularly for advanced node design. Any further tightening of restrictions could reduce Cadence's revenue, which has historically been a meaningful contributor. Fourth, acquisition integration risk. Cadence has been an active acquirer, and each acquisition, from Beta CAE to OpenEye Scientific, needs to be successfully integrated, cross-sold into the existing customer base, and harmonized into a coherent product strategy. M&A is inherently risky, and not every acquisition will deliver on its thesis. Fifth, the AI disruption risk cuts both ways. While Cadence is using AI to enhance its tools, there's a longer-term question about whether AI could eventually disrupt the EDA model itself. Because if AI systems became capable of designing chips with significantly less human engineering, and therefore less need for traditional EDA licenses, the market dynamics could shift in unpredictable ways. This is a speculative risk, but one worth noting given the pace of AI advancement. And six, valuation. Cadence trades at a premium. It's pricey, and that reflects its exceptional business quality and growth strategy and trajectory. If growth decelerates due to a semiconductor design slowdown, competitive share loss, or macro pressures, the multiple could compress significantly. So where does Cadence go from here? I'd argue it sits at the intersection of virtually every major trend driving the semiconductor industry forward. Starting with AI, every major technology company is designing custom silicon for AI workloads. Google has its TPU, Amazon has its Trainium and Inferentia, Microsoft has its Maya, Meta has its own custom accelerators, and these are some of the most complex chips ever designed, and they all need EDA tools. More custom chip programs means more EDA consumption, more licenses, more verification hardware, more IP blocks. Then consider advanced packaging. The move to chiplets, 2.5D and 3D integration, heterogeneous architectures create entirely new design challenges. You need tools that can handle multi-die systems, die-to-die interconnects, thermal co-optimization, and system-level electromagnetic analysis. And Cadence has been building precisely these capabilities. The automotive market is another massive driver. Modern vehicles contain hundreds of semiconductor devices, and the move towards autonomous driving, electrification, and software-defined vehicles is dramatically increasing the design complexity of automotive chips. Cadence has invested in automotive-specific verification and safety analysis tools that address the unique requirements of this market. And the system design expansion opens up entirely new markets. Computational fluid dynamics for aeronautical design, molecular simulation for drug discovery, data center thermal management. These are markets where Cadence's core competency in computational simulation and AI-driven optimization can create significant value, and they're markets that have nothing to do with the cyclicality of the semiconductor industry. Anirudh Devgan's vision for Cadence, transforming from an EDA company into a broad computational software platform, is ambitious. But the building blocks are in place, right? A dominant position in chip design tools, a rapidly growing system design portfolio, AI-powered products that deliver measurable productivity gains, a massive and growing backlog, and a financial model that generates abundant cash to fund continued investments and acquisitions. So that's Cadence Design Systems, the company whose software is used to design virtually every advanced semiconductor on the planet. The invisible layer of the chip industry that sits between the idea for a chip and the physicality part and reality of silicon. So when people talk about AI infrastructure build-out, the GPUs, the custom accelerators, the networking chips, the high bandwidth memory, they're talking about chips that were actually designed by Cadence tools, verified on Cadence hardware, and built with Cadence IP. Every time the semiconductor industry pushes to a smaller node, a more complex architecture, or a more ambitious chip, the engineering challenge grows, and the value of the software that makes the design possible grows with it. So in a world that designs more chips, more complex chips, and more kinds of chips than ever before, Cadence occupies one of the most durable and strategically important positions in the technology's landscape. It's the architect's architect, the designer's designer, and under Anirudh's leadership, it's becoming one of the most important AI companies you've never thought of as an AI company. So that's all for this episode of Quick Chip under the Semiconductor Leadership Podcast. If you enjoyed this deep dive, please make sure to subscribe, leave us a comment, or share it with someone who should understand the software infrastructure that makes the entire chip industry possible. Until then, it takes a village to raise a chip. Take care and see you at the next episode.